Classification of polymers. A polymer is a naturally occurring or synthetic compound, such as starch or perspex, that has a large molecule made up of many relatively simple repeated units. The repeating structural units are known as monomers. These units are linked to each other by covalent bonds. The word polymer is coined from two Greek words. Poly means many and mer means unit or part. Sometimes polymers are also known as macromolecules or large-sized molecules. The process of formation of polymers from respective monomers is called polymerization. Ethylene, ethene, is the monomer of linear polymer called high-density polyethylene, HDPE. N CH2 double bond CH2 ethene upon polymerization gives N CH2 CH2 repeating unit gives CH2 CH2 whole N polythene polymer. Polyethylene is equal to ethylene, 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 ethylene. Classification of polymers. Classification based on source. There are three subcategories. Natural polymers. These polymers are found in plants and animals. Examples are proteins, cellulose, starch, etc. Semi-synthetic polymers. Examples of this category are cellulose acetate, rayon, and cellulose nitrate, etc. Synthetic polymers. Plastic, polythene. Synthetic fibers, nylon, 6, and synthetic rubbers, Buna S, are examples of synthetic polymers. Classification based on structure of polymers. Linear polymer. A polymer consisting of a single continuous chain of repeat units. The examples are high-density polythene, polyvinyl chloride, etc. 2. Branched polymer. A polymer that includes side chains of repeat units connecting onto the main chain of repeat units. Low-density polythene is an example of branched polymer. Cross-linked or network polymers. These are usually formed from bifunctional and trifunctional monomers and have strong covalent bonds between various linear polymer chains. Example: bakelite, melamine, etc. Classification based on mode of polymerization. Addition polymers. An addition polymer is a polymer which is formed by an addition reaction where many monomers bond together via rearrangement of bonds without the loss of any atom or molecule. Most of the common addition polymers are formed from unsaturated monomers, usually having a double or triple bonds. Formation of polythene from ethene and polypropene from propene are examples of addition polymers. The addition polymers formed by the polymerization of a single monomeric species are known as homopolymers. Example, polythene. The addition polymers formed by the polymerization of two different monomers are known as copolymers. Examples are Buna-S, Buna-N, etc. Condensation polymers. Condensation polymers form when bifunctional or trifunctional monomers react to form a long-chain polymer molecule. Small molecules such as water, alcohol, hydrogen chloride, etc. are eliminated during the reaction. Polyesters, polyamides, proteins, and polysaccharides such as cellulose are all examples of condensation polymers. Classification based on molecular forces. On the basis of molecular forces, the polymers are divided into the four subgroups. Elastomers. Elastomers are rubbery material composed of long chain-like molecules or polymers. They are capable of recovering their original shape after being stretched to great extents, hence the name elastomer from elastic polymer. In these elastomeric polymers, the polymer chains are held together by the weakest intermolecular forces. The examples are Buna-S, Buna-N, neoprene, etc. Fibers. Fibers are the thread-forming solids which possess high tensile strength and high modulus. The examples are polyamides, nylon 6,6, polyesters, terylene, etc. Thermoplastic polymers. Thermoplastic materials are those materials that are made of polymers linked by intermolecular interactions or van der Waals forces, forming linear or branched structures. They become moldable above a specific temperature and solidify upon cooling. Most thermoplastics have a high molecular weight. Some common thermoplastics are polythene, polystyrene, polyvinyls, etc. Thermosetting polymers. Thermosetting plastics are polymer materials which are liquid or malleable at low temperatures, but which change irreversibly to become hard at high temperatures. These polymers are cross-linked or heavily branched molecules. Some common examples are bakelite, urea formaldehyde resins, etc. Classification based on growth polymerization. The addition and condensation polymers are nowadays also referred as chain growth polymers and step growth polymers. Chain growth polymerization is a polymerization technique where unsaturated monomer molecules add onto the active site of a growing polymer chain one at a time. Addition of each monomer unit regenerates the active site. polyethylene, polypropylene, and polyvinyl chloride (PVC) are common types of plastics made by chain growth polymerization. Step growth polymerization refers to a type of polymerization mechanism in which bifunctional or multifunctional monomers react to form first dimers, then trimers, longer oligomers, and eventually long-chain polymers. Examples are polyesters, polyamides, polyurethanes, etc.